Today we are going to discuss electrophilic substitution on benzene. So electrophilic substitution on benzene is nothing but the substitution of electrophile on benzene ring. Substitution of electrophile. So first, what is electrophile? Electrophile is nothing but electron deficient species. Electrophile is nothing but electron deficient species which always carries the positive charge. Which always carries positive charge. So we will represent like this, and this is called as a electrophile. This is called as a electrophile. So when the electrophilic substitution occurs, where the electrophilic substitution occurs, where the electron rich position is there on the any compound, that electrophile can be substituted on the electron rich position. For example, we take benzene ring. We take benzene ring. So this is the benzene ring. Okay. Now electrophile is here. Electrophile is here. Now the pi electrons moves to this carbon. The carbon will get the negative charge. Pi electrons moves to the carbon. Carbon will get the negative charge. On that carbon, this electrophile can be substituted. If electrophile, how it substituted on the benzene ring, that we will see in the mechanism. For example, electrophile is substituting on this carbon. So what is going to happen here? We will see. So here already hydrogen is there. The electrophile is substituted on this carbon. So these pi electrons are moving this carbon. Carbon will get the negative charge. That means electron rich carbon. And this carbon is getting the negative charge. Automatically this carbon gets the positive charge. Because this carbon is losing electron. And we know that the substrate or any species which is gaining electron gets the negative charge, and which is losing electron, that gets the positive charge. So now this carbon got negative charge, so that's why this electrophile is substituted on this carbon. Now we have the positive charge on this carbon. Remaining two double bonds are here on the benzene ring. So what happens here? These pi electrons will shift to here to neutralize the positive charge. Okay. Now the double bond is moved here, and if this double bond is here, and what is the charge will be present here? What is the charge supposed to get this carbon? Open your mouth and tell me. Positive charge or negative charge? Positive charge. Positive charge. So positive charge, and this hydrogen will be as such, electrophile will be as such. Now this positive charge can be neutralized by getting the pi electrons shifting from here to here. Okay. When the pi electrons are shifting here, here, and here double bond will be there, and here it gets the positive charge. It gets the positive charge. Okay. Understand? So these are the resonance canonical structure of benzene. Canonical structure of benzene. And the resonance hybrid can be shown like this. Can be shown like that. What is the charge it is getting delocalized positive charge? So that you have to write it as a positive charge in the benzene ring, and you have to this is called resonance hybrid. Resonance hybrid. Okay. So after here All of you understood? This is the mechanism how the electrophilic substitution occurs on the benzene. So up to here, all of you understood? So the next step, what happens? The positive charge here will be neutralized by getting the electron from the hydrogen, and the hydrogen will be leaving as H plus. Okay? Okay? Understand? This is the mechanism. Okay? Now we are going to discuss about the different type of electrophilic substitution on benzene. So in different type of electrophilic substitution on benzene, for example, what are the electrophiles are there? Halogenation is the electrophilic substitution, nitration is the electrophilic substitution, sulfuration is the electrophilic substitution. So these are the examples for the electrophilic substitution. So how these reactions involves on the benzene, that we are going to discuss. Understand? So is there any doubt? Okay. Next we are going to discuss the halogenation. Halogenation is the one of the electrophilic substitution reaction. So in which halogen is the electrophile. In which halogen is the electrophile. So first, halogenation. First we will see the reaction, then we will see the mechanism. Benzene undergoes electrophilic substitution with halogen like chlorine or bromine or iodine in the presence of Lewis acid catalyst. Lewis acid is nothing but FeCl3, FeBr3 or such type of substitutions of Lewis acids, and you are going to get the halo substituted benzene. For example, this is the benzene, and this is the chlorine, and here you have to chlorobenzene. Now, mechanism, how it involves how the halogenation reactions occurs on the benzene, that we are going to discuss. Okay. So here, step 1. Step 1, what happens? This halogen reacts with the Lewis acid to give the electrophile. Step 1. Halogen reacts with the Lewis acid to give the Cl plus FeCl4 minus. So here Cl plus is the electrophile. Understand? Cl plus is the electrophile. Now this Cl plus undergoes electrophilic substitution as we have discussed in the mechanism in the previous reaction. The same thing happens here. So positive charge comes here, H, Cl will be here. Okay. Next, what happens? These pi electrons will shift here and it forms as a positive charge. It forms as a positive charge. Okay. Now H, Cl is there. Again, this pi electron shift here and it forms that here double bond will be there and here positive charge, here H, this is the Cl negative, Cl. Okay. Now this reaction up to here, the reaction go slowly. The reaction go slowly and this is the slow step. This is the slow step and this is the step 2. This is the step 2. Okay. Now step 3, what happens? You see. Step 3, what happens? You see here. The third step, this is the final step. Third step, step 3. Step 3, what happens? This positive charge are here, and you have here FeCl4 in the reaction medium, right? FeCl4 also is there in the reaction medium. So this FeCl4 will be on reaction medium. So this hydrogen gives electrons to the benzene ring and it forms that fluorobenzene plus this H plus 1 Cl will be taken from the FeCl4 and it forms as a HCl, and again the FeCl3 will be regenerated. That FeCl3 again it involves in the electrophilic substitution, again it gives that one more of the fluorobenzene. So that FeCl3 will be regenerated and it will be recycled. Okay. So this is the fluorobenzene, and this is how the halogen substitution occurs on the benzene. Okay. Is there any doubt?